going to now apply Kepler's third law to an actual problem. You can see that picture of our ellipse here back in the 1800s. But you can see we have an ellipse, this is our shape here. This is our perimeter of our ellipse. Going from the middle to the end or the perimeter of the ellipse is our semi-major axis, and that little dot would be our focus. Now, we went through Kepler's third law and said T is the period that's going around the ellipse, and that's being squared and is equal to the cubed of the semi-major axis, which is this. Now, we're going to actually apply this law. If Jupiter has a period of 11.87 years, what's the diameter of its orbit? Now, just keep this part in mind as well. The Earth has an orbit, or the Earth is 1 astronomical unit away from the sun, or that's equivalent to 1 AU is equivalent to 93 million miles. You should know this already by this point in the course. We are 93 million miles away from the sun, and that's considered 1 AU. Okay, so we're going to actually solve for the number of AUs Jupiter is away from the sun. And it better be more than 1 because we know that the Jupiter is further out in its orbit, and we know that it's a different composition. It's a gas planet. It's not the same as the Earth. We know from the last chapter that the Earth is in the Goldilocks zone, or the zone of habitability. Jupiter is not. So basically, it's taking Jupiter about almost 12 years to orbit the sun. Rather, it takes us 365 days. So let's solve this. It's pretty easy math, actually. So we know that this is the period. So all we're going to do is put 11.87, and we are going to square it. And then that's going to be equal to A cubed. So let's get out our scientific calculator, and we're going to say 11.87, and we are going to say x to the y, and we're going to square it, and that's going to give us 140.8969. So let's write that on our whiteboard. 140.8969. But we know that's A cubed. We've got to get rid of that cubed and solve for that semi-major axis. So to get rid of the cube, we're going to actually take the cube root of that value. So we're going to then plug this number, which is already sitting in our calculator, and we're going to take the cube root. And that's going to give us the amount of astronomical units that Jupiter is away from the sun. So let's take our calculator. 140.8969 and take the cube root of that, and that should give us about 5.2 astronomical units. We're just saying is 5.2 astronomical units away from the sun. And that sort of makes sense because 1 astronomical unit is 93 million miles. So we can actually multiply 93 million miles times 5.2 and get our actual distance in miles for Jupiter away from the sun. But this is how we apply Kepler's third law of periods and how it's calculated. But also, as a reminder, we have the law of orbits, that everything orbits in an elliptical pattern. We have the law of equal areas, stating whatever place that the planet is along this ellipse, it is at an equal amount away, or equal area away from the sun. And we also have our third law, which we just demonstrated right now. And this applies to the planet Jupiter, but it also can apply to comets. If we find a brand new comet out there, if we can get the measurement of its semi-major axis, we can determine its period. Or if we know its period, we could determine its distance away from the sun. So these laws are very important in astronomy here. So if you have any questions on Kepler's law, please be sure to contact your teacher.